Looking at figure 5, we're told to go ahead and rotate the figure 60 degrees counterclockwise using center B. So we're going to identify our center B. This is our rotation point. Everything will rotate around this point, and we're talking counterclockwise, so we want to go ahead and rotate this direction away from the clock. So 60 degrees, this is where this type of grid helps us out. Each of these little triangles, keep in mind, every single angle in here, this little angle right here to here is 60 degrees. So when we rotate, we want to actually take, let's go for reference, we'll take this side, the line containing segment AB, and we're going to rotate that one 60 degrees. So we're going to use this little edge of the triangle to help us to see the 60-degree line. With a little piece of tracing paper, we can go ahead and trace our figure, quadrilateral AB, CD. And what we're really going to pay attention to is just segment AB, because that's on our line right here. And then we're going to follow our line underneath until we get AB to snap to this line right here. So as we rotate for around center B, keep going, keep going, keep going, keep going, keep going until here. And we know that this is 60 degrees because I've taken this edge, segment AB, and the line containing that, and followed it over here. So now the key thing is going to be I'm going to lift up my paper, my tracing paper, and I'm going to go ahead and put those points onto my grid. So right there is one, that's point A. So we call that one A prime. This one just below it is D prime, and then C prime will be here. B prime will continue to be on the same point, and then I just connect my points together to create my quadrilateral again. There you go. Let's try that again. This time we'll do that with figure 6. So same figure right here. So the cool thing about this tracing paper, all these shapes are the same size. I should be able to do the same thing. Now let's look at what they say. We're going to rotate the quadrilateral again 60 degrees clockwise using center C. So here's my center C, and we want to go clockwise this time. So this time we're going to go this direction. And so clockwise for this, let's look at where we're at. If we're at center C, let's go ahead and use this edge right here containing segment CD. And we're going to rotate that one 60 degrees. Again, keep in mind this is where D, A, B, and C were. And now 60 degrees, so we're going to take this one. Let's look where 60 degrees clockwise would be. 60 degrees clockwise, remembering that these triangles are 60 degrees in each vertex, we're going to get that segment CD to go ahead and snap to that portion right there. So here we go. Keeping it on point C and rotating 60 degrees, and we can see that this side right over here, segment DC, is going to rotate. We're just focused on that. Everything else will follow right along where it's supposed to until we get to the line. We stop, and then we'll go ahead and move our paper, and we'll mark this one for point D, this one for point A, and point B. So here we go. D prime, A prime, and B prime. C prime will also be right here. Sketch it, and we have a completed shape that is now a 60-degree clockwise rotation. Figure 7 tells us that we're going to reflect using line L. I like this one. We can use it for the patio, or we can use our tracing paper in this way. This is kind of cool because if we take our paper like this and take the line of reflection, I'm going to pick one point just to mark this off of. So I'm ending right here below the L. And then we can take our paper and we can just flip it over. And this will be a reflection. This is what our image should look like by the time we're done. And if for some reason it doesn't, then we need to redo our work. So I know it's going to be right here. Here's another way that we can look at the reflection. I know my reflection has to be perpendicular to where it's at currently. So if I think about just having a straight line pointing across going down through this triangle. It comes down through the middle of one triangle. That means that point D prime must be the same distance away from that triangle. So A prime, I'm going to kind of count through the horizontal of the triangles. There's 1, 2, and then on the other side of the line, I'm going to count 1, 2, and I get A prime. Let's do the same thing with C. 1, 1, and then B. 1, 2, 1, 2. B prime. We can sketch in our figure. Notice that all of these pieces, when we're talking about a reflection, are going to be the exact same distance away from the line of reflection on either side of the line, always perpendicular to where they were across that line. Feel free to go ahead and use your tracing paper to also flip that over. That will work. The final one on figure 8, we're going to translate the quadrilateral so that A goes to C, meaning I want this one to end up right here. So I want to move my whole figure across. I want to be able to take this one over to here, but I need it to look the exact same. Tracing paper is very helpful for this, but what we want to do is follow along some kind of a vector, as we saw that. That vector would be the piece that goes from A to C. Remember, a vector is a directed segment. We're just moving that many units to the right. In this case, we're going to count those triangular units going that far. So if we move this one to here, this one will become A prime. But how do we do the other ones? Well, here's something that I notice. I notice that AD is a vertical line. So when I move it, it also has to be vertical. I recognize that D is 1 unit below A, so then D prime must be 1 unit below A prime. I know that C, getting from D, this one also must move 2 units across the exact same way, or have the same length there. C prime must be here. And I can check that and say, okay, well, D, if I go diagonally along this line, I see that that's 2 units diagonally. So I'm going to look from D prime to C prime and verify that that's also 2 units diagonally. So far, my shape is showing up like this. I need to do letter B now. Again, the same rule as right here at the earlier vector from A to A prime. It appears to be kind of a 2 diagonal, or 2 units horizontally. It's not exactly 2 because the lengths are a little bit different, but I'm going to use that just as a reference. And so I'm going to count across to the line, then to the next diagonal set to make B prime, connect my dots here, connect the dots along this line, and I should see the exact same shape again. I can verify this by using my tracing paper, following along that vector to verify that we have the exact same shape. Hopefully this is a little bit of a helpful tutorial. Let me know if you have any questions.